Hello, I'm Dr. Q. Welcome to my channel. This is the 13th class of Principles of Economics. In this video, I continue covering firm theory and focus on the production costs in the short run. Please remember that short run provides long enough time for business or firm to change the output by adjusting some of the input quantity used, but is too brief to change the production capacity, such as plant size. In Lecture 11, we learned that in order to produce goods or services and sell for money, businesses and firms have to employ economic resources for production. During the process, costs of production are incurred. Let's look at the census manufacturer statistics. Companies have a wide range of different costs associated with their business. There are labor costs, including salary, benefits, health plan, etc. There are costs of supplies and/or materials, energy, utilities, etc. There are also expenditures for buildings, structures, machinery, and equipment, including depreciation on equipment and buildings. Other expenditures include rental payment, computer hardware, data processing, communication, repair and maintenance service, taxes and license fees. In the short run, some of those costs do not vary with the change in output. They are called fixed costs. Fixed costs are expenses that have to be paid by a company, independent of any specific business activities. They have to be paid as a fixed amount of money, no matter how many goods or services produced, even if its output is zero. Let's think about what expenses a firm may have even if it does not produce anything at all. A lot of businesses do not own the building or space. They have to pay the rent, which is normally paid once in several months, or biannually or annually. During the contract time, rent has to be paid by the business or firm, independent of the production level. This is true for any payments under contract agreements or schedules, such as management salaries. If business takes loan from bank for production, interest payment belongs to fixed costs. Other fixed costs include depreciation on equipment or buildings and insurance premiums. Some licensing fees paid to the government could also be part of the fixed cost, if the payment does not vary with the changes in output. This is the hypothetical data I derived from the census manufacturer statistics. chocolate production sector in North Carolina. The first column here is the quantity of output or total product. The abbreviation Q as quantity is in millions. So the 0 means no chocolate bar is produced. Then 1 million bars produced, 2 million chocolate bars, 3 million, up to 10 million. The second column is the monetary value of total fixed cost. The initials TFC are the abbreviation. It's in $1,000. We can see that the total fixed cost is always $50,000, no matter if the factory produces no chocolate at all, or 1 million, or 10 million. The fixed here means it's a constant number and does not change with respect to the change of output. The other component of the production costs is variable costs, such as expenditures on labor, utility, raw materials. It varies with respect to the quantity of output produced, so it's called variable cost. The more chocolate the factory produces, the higher this part of cost, as they have to hire more workers, purchase more cocoa beans, sugar, milk, and butter, and use more power. Other variable costs may include transportation services and fuels. The third column provides information for total variable costs, TVC, in $1,000. When no output is produced, there is no variable cost. As more chocolate bars are produced, the total variable cost also increases, but we can see that it's not increasing with a constant number. I will discuss why in a few slides. Lastly, the summation of a fixed cost and a variable cost is total cost. And that's how we get information for total cost in fourth column. Now, plot the observations on two-dimensional axis set. The blue line is horizontally fixed at 50, no matter how the total product changes. This is a total fixed cost curve. The green line is the total cost, and the orange line is total variable cost. We can see that the two of them are parallel to each other. The distance between the total cost and total variable cost is total fixed cost. And the distance between total cost and the total fixed cost is total variable cost. As shown over here. So, for the three variables, knowing two, we can figure out the third one. From total cost, we can figure out the marginal cost. Marginal cost is the extra or additional cost generated by producing one more unit of output. Marginal cost can be determined for each added unit of output by noting the change in total cost entailed by that unit's production. Here, the output quantity changes conveniently by 1 unit, so the denominator is always 1. The difference of total costs that are adjacent to each other provides us the corresponding marginal cost. There is another way of calculating marginal cost. Pick output equals 4 and output equals 5 as an example. Since the total cost is the summation of total variable cost and the total fixed cost, the change in total cost can be rewritten as the following. So each total cost has a total fixed cost, but total fixed cost never changes. They're cancelled out. So the change in total cost essentially is the change in total variable cost. Total variable cost solely contributes to the change of total cost. Therefore, there are two ways of calculating marginal cost, using change in total cost or total variable cost. Now, let's move on to the average costs. Total cost is the summation of total fixed and total variable cost. Divide everything by output quantity. Each of them is the corresponding average cost. Total cost divided by the output quantity is the average total cost. Total fixed cost divided by quantity is the average fixed cost, and total variable cost divided by quantity is the average variable cost. The equation 2 can be rewritten as equation 4. Average total cost is the summation of average fixed and average variable cost. From this formula, knowing 2, we can figure out the third one. Meanwhile, knowing the average and the quantity of output, we can figure out the corresponding total. Total cost is the product of average total cost and output quantity. Total fixed cost is the product of average fixed and output quantity. Total variable cost is the product of average variable cost and output quantity. There are a lot of formulas, and this part can be technical, but they're essential to understand firms' behaviors we're going to cover in future lectures. So please make sure you understand the rationale. We'll do several practices to apply this into calculation in a few slides. Here are a summary of the formulas. Please pause and make sure you're following along. If we plot the observations of marginal and average costs into two-dimensional axis set, the output quantity on horizontal axis and the costs monetary value on vertical axis. This is what we get. There are 4 curves. Let's look at the average fixed cost curve first. It's downward sloping, always decreases. This is intuitive, as the numerator total fixed cost does not change, is 50, but from left to right on horizontal axis, quantity increases, so the ratio of the two declines. Now, let's look at the average total cost and the average variable cost curves. Both of them are of U shape, which means when total product Q increases. Average total and average variable costs at first decreases, achieve their minimum values, and then increase. The two of them are very similar. Average total cost curve is on top of average variable cost curve. The gap between the two of them is actually the corresponding average fixed cost. The same is true everywhere, as average fixed cost can be calculated as the difference between average total cost and average variable cost. The gap between the average total cost and average fixed cost is the average variable cost. It's true everywhere. As the difference between average total cost and average fixed cost is the average variable cost. After discussing the relationships among average costs, let's look at the marginal cost. Marginal cost curve is also of U-shape. It declines at first, achieves its minimum value, then increases. It just achieves its minimum value before average variable or average total cost curve does. Marginal cost is the slope of total variable cost and total cost. That's why they increase with a decreasing rate first, and then increase with an increasing rate. So flatter at the lower left and steeper on higher right. Focus on marginal cost and average variable cost curve first. They are equal to each other when the output is 1. When marginal cost curve is below average variable cost curve, which means marginal cost is smaller than the average variable cost, it pulls the average variable cost down. Average variable cost declines. When marginal cost crosses average variable cost curve, which means they're equal to each other, average variable cost achieves its minimum value. When marginal cost curve is on top of average variable cost curve, which means marginal cost is larger than average variable cost, it pulls average variable cost up. Average variable cost increases. The same is true between marginal and average total cost. The rationale for the relationship between marginal and average is fully discussed in Lecture 2 and Lecture 12. I'm here to summarize it. When marginal is below the average, it pulls the average down. Average decreases. When marginal is above the average, it pulls average up. Average increases. Marginal always cross average at average's extreme value. The extreme value can be maximum, the largest, or minimum, the smallest. Here, cost has minimum value. Now the question is, why are those cost curves of U-shape? In particular, economists are interested in the marginal cost because the marginal decision matters. Firm can control directly and immediately about the marginal cost, which is the cost incurred in producing the last unit of output, or the cost that can be saved by not producing the last unit. Remember, the firm needs to compare the marginal revenue against the marginal cost to decide on the optimal output. So why does the marginal cost curve look like this? It at first declines sharply, reaches a minimum, and then rises rather abruptly. It's actually because of the law of diminishing returns that we covered in Lecture 12. This is the data we used in Lecture 12. The number of workers in first column increases by 1 unit. Suppose that each worker can be hired for $10. Then the extra cost associated with another worker is $10. Because the first worker produced 10 units of output, the extra cost of each of these 10 extra units of output is $1. Hiring the second worker also costs the firm $10, but the second worker produces 20 extra outputs. So the marginal cost of each of these 20 extra units of output is 50 cents. We can keep calculating. But eventually, the extra output brought in by one more worker who costs $10 declines. So the marginal cost of one more output increases. In order to make intuitive graphs, the data from Lecture 13 is not necessarily consistent with the ones in 12, but the rationale applies. Within the same production period, the marginal cost curve and the average variable cost curve are mirror images of the marginal product curve and the average product curve. The maximum value of marginal product should correspond to the minimum value of marginal cost, while the maximum value of average product curve should correspond to the minimum value of average variable cost. And the law of diminishing marginal return results in the shapes of the curves. Please note that this makes sense, as we simply flipped the vertical variable and the horizontal variable of the top one to get the bottom one. The only difference is that the quantity of input on product curve is expressed in its monetary value on vertical axis for cost curve. So as opposed to hire one worker, we mark as $10 because one worker costs $10. Let's do some practice. This table asks you to fill up the blanks with the given information. Please pause and do it yourself and say if you can fill everything up. Alright, this table may feel overwhelming at first sight, but take a deep breath. The first information you should fill up is total fixed cost. because it never changes. The second column you can fill up is total cost. There are two ways. You can do a summation of total fixed and total variable cost. Alternatively, you can use the product of average total cost and corresponding output. So total cost can be calculated this way. The total variable cost can be calculated as the difference between total cost and total fixed cost, or the product of average variable cost and output. This is a total variable cost. The marginal cost can be calculated as the change in total cost since the total output always increases by 1. You will get the same result by calculating the change of total variable cost. Actually, you can get total cost by adding the previous total cost with the current marginal cost. The same rationale is true to total variable cost. The average cost can be calculated by dividing the total with the corresponding output quantity. Alternatively, knowing two of the averages, you can figure out the third one. Next one. Please pause and come back. Alright, the first step is you're supposed to know what cost curve each of those represents. From what we learned, I'm not saying you have to draw some pretty curves like this by yourself, but you're expected to know their relative positions and relationships. This is it. Obviously, you can find average fixed cost by tracing from Q up to the average fixed cost curve. So MN is correct. The parallel PO is also correct. Average fixed cost can also be shown by the gap between average total and average variable cost. So JK and SR are all correct. Next one, pause and come back. Alright, the question asks us to find the area representing total cost, while all curves are averages or marginal. So we need to use the formula of the product of average total cost and output quantity to calculate total cost. At Q, the average total cost is JN. The output is Q or ON. The product of the two is actually the area of this rectangular area, ONJS. With the same rationale, total variable cost can be calculated by ONKR. Or PMGS, as average variable cost is the difference between average total cost and average fixed cost. Total fixed cost can be represented by ONMP or RKGS. Let's practice. Please pause and come back. Alright, in order to answer the question, we need to use this knowledge point. Marginal cost and average variable cost are equal at the output when average product is maximized. Alright, that's all I have for this video. In next lecture, I will cover long-run production costs. Thank you for watching. Please like and save the video and subscribe my channel for more lectures in economics.